Alrighty, here we are. We're here on the fourth problem of these five sample free response questions. I've made videos for the first three questions. Here's the video for the fourth question. There was some questions on what you guys had time to provide some questions or comments on this free response question on anything that you did not understand or that you had questions on. And so I'll go over this. I have not coded this game, but it seems pretty straightforward. Quite a few of you asked about using math.random. Well, you have to use math.random. There's also questions on typecasting and when typecasting might not work. There's as well questions on inclusivity. Well, how do you make it inclusive on using for loops, if statements? I don't think there's too many questions on what is being asked by this problem, so that seems to be somewhat straightforward. But let's go ahead and start here. I'm going to copy this and I'm going to paste it in a new file, a new Java class. And so we have the SpinnerGame. If you click here, you hold the Shift key, and then you click down here. It highlights everything in between. You click Tab, and it indents for you. And this is just for it to look nice. And what we're gonna code here are two methods. The first method is called spin. This is to be implemented in part A. And then the next method is play round, which is to be implemented in part B. So there's two methods. I want to make a note here that neither of them are static methods. So what we have gotten away with in the past by coding the main method within, I won't do it that way this time. I could make these two methods static if I wanted to, and just code the main method within, but it serves us well to just look at an example of having to instantiate a SpinnerGame object. So creating an instance of this class, an object, if you will. And so I won't take that route. I won't code the main method. We'll have a SpinnerGame test class. I'm gonna compile. This is supposed to return an integer, so if I compile, I'm going to get an error. So I'll put here return just a 1 for now. This is void of a return, so it's not supposed to return anything. If I compile, it's going to prompt me to save. And so I'll go to my directory, my location here, where I've saved these documents. It's the computer science class for response questions. And we have the SpinnerGame. So it compiles without error. Now let's look at the problem statement here. For part A, simulates the spin of our first spinner. The method returns a random integer between min and max inclusive. Again, inclusive. Inclusive means that the random number can be min and max, whatever those two values are. So suppose somebody says min is going to be 3, max is going to be 10. And so you want a random number between 3 and 10, including 3 and 10. And it is supposed to be random, so that's key. They don't specify how to make the random value, but we'll talk about that as in our implementation here. Precondition, again, these preconditions are meant to be safeguards so that you don't have to worry about somebody sending numbers that might break your code. So you don't have to worry about that. The precondition is that min is less than max, always. Not equal to, less than, okay? So min is always going to be a number less than max. You're given some information. It simulates a spin of a spinner by returning a random integer, and that's key here, that it has to be an integer between min and max inclusive. There's something to be said about the integer result. It says that complete the spin method below, assigning this random integer to result. So whatever we get, we need to restore it here. Okay, so let's go here in our implementation. Let me first start by talking about random numbers. We've talked about using math.random. Now, math is a Java library. So it's basically a class that we have access to. We don't care about what's in it necessarily. Well, we do care about what's in it. We don't care about how it does what it does. We do care about the methods that are in this class. And in the math class, there is a method called random. Now, we've worked on this in class multiple times, so let me just remind you what math.random does. This random method in the math class generates a random double, so it's not an integer, between 0 and 1, non-inclusive of 1, okay? It's never going to be 1. So you could get values between 0 and 1. Notice that those values would always be decimal values, like 0.5, 0.9, 0.98. You could get potentially 0, although I would think maybe that would be really hard, like 0.0. So between 0 and 1, but not including 1. So that's how it works. That's really all we have to know, okay? As far as how this math.random works. Now, what we need to do here is we need to typecast. So we need to do a few things. We also want the random number to be the number between min and max. Now, let me first make the spinner the tester class so that we can play with the math.random within that class before we try to code it in here. So I'm going to make a class. Oh, come on. Public class SpinnerGame. Tester or test or driver, whatever you want to call it, but this is going to test the SpinnerGame class. In here, I'm going to have the static method, public static void main. Remember that control, when you run a class, the control is always given to the main method, meaning the main method is the one in control. And so within here, I want to just make a variable int, actually a double. I'm just going to call it random for lack of a better name, and it's going to be math.random as such, and then I'm going to print that variable random. I'm going to compile. It's going to ask me to save. I need to save in the same directory as my SpinnerGame, because I'm going to be testing the SpinnerGame class from this class. And so there we go. And then I'm going to run. And you see this is a double. It's actually a very big number. It is a decimal value between 0 and 1. If I run it again, I would not expect to get the same value. I don't have to recompile, by the way, okay? Compiling once is enough. Notice how there's two different, these are random values, right? So random. So I'm going to run it one more time. Now let's say that I wanted a random number between 0 and 10. Well, notice that if I want this, for example, 0.5, let me just call it 0.54. If I want it to be a number between 0 and 10, I would just have to multiply by 10, and it would give me 5.4. Here, this is 0.76. Multiplying it by 10 would give me 7.6. And right here, 0.44 multiplying it by 10 would give me 4.4. And so if I go up here to my code and I'd say 10 times whatever math that random is, now I'm expecting, I'm going to recompile because I made a change. You see now I'm getting a random numbers between 0 and 10. It's never going to be 10, by the way, because this is never going to be 1. Math.random will never give you 1, and so 1 times 10 is 10. So this will never be 10. At most 9.9999, whatever you want to call it, but you see right here we're actually getting close. Let me run it one more time. 7.54. Good. Now let's say that you wanted to make your numbers just integers, whole numbers. You don't want the decimal. Well, that's where we get into typecasting. This is the result of multiplying a double, because math.random gives you a double, times an integer. 10 is an integer, and multiplication, the result of multiplying these two would be a double as well. Now, if I want to make it an integer, I can typecast this, and we typecast by, at the very front, putting the data type that we want, int, within parentheses. And I'm not multiplying. Notice that I'm not putting times. No, this is an operation. Typecasting is an operator. It lets us change the data type. So I'm gonna multiply this value, whatever I get, in this case like maybe 7.54, and then I get 7.54, and then I want to change that to an integer, and what it does is it forgets anything after the decimal, so it would just be 7. Now that means I need to store this in an int now, and I can run this. Incompatible types. Okay, let me do the following. Let me put this whole operation within parentheses. And there we go. I only got 10. I mean 1. Let me run it one more time. 1, 3. There we go. Okay, it's working. 2, 6, 3, 2. It's kind of sticking to the lower values. Who knows why? But okay. Good. Now, right as I have it here, this gives me a random value between 0 and 9. And it's never going to be 10. So multiplying by 10 gives me a random number between 0 and 9. Now let's say that I want a random number between 5 and 15. I guess maybe let's do, okay, let's say between actually 0 and 10. So 0 and 10. Well, then I would have to then go 1 up and multiply by 11. You'll never have 11. At most you'll have 10. So if I compile, I forgot my semicolon. There we go. If I compile and run, okay, 2, you'd have to do this forever. I mean, a loop would probably be best. Yeah, there we go, 9, there we go. Finally, we got 10. So it works now. So now between 0 and 10. Now let's say that you wanted a random number now between 5 and 15. Well, then I would say, okay, well, my smallest number, which is 0, if I want my smallest numbers to be a 5, then to my smallest number I have to add 5. So, and then adding 5 to 10 would give me 15. And so if I say, okay, well, whatever I get from whatever random number I get between 0 and 10, whatever it is, let's add 5 to it. And now this is after the parentheses plus 5. And if I compile now, I'm going to get at the lowest number I'm going to get, the lowest value is when this evaluates to 0. This random value is 0 plus 5 is 5. That's the smallest number I'll ever get. Remember, this is never negative. 11 times math.random is never negative. The biggest number I would get from here is a 10, and adding 5 would make it 15. And so adding 5 here changes my minimum and my maximum. It increases them by 5. If you wanted negative values, you could like say -5 and +5, then you could subtract 5. Now, without actually making note of this, this is basically the implementation we need right here. This is it, the implementation we need in our method here, in our spin method. The lowest number I want is min, and so min is going to take the place right here of that 5. Let me, as a matter of fact, just copy these. Copy this. I'm going to copy it. And I'm going to remember they had the variable int result in the problem statement equals. Let me just take you back. I put 2 equal signs here. Let me take you back to the problem statement. I guess it timed out on me. Okay, here we go. It had timed out on me for some reason. But here's the spin method. It says store the random number in this variable result and then return result. And so that's what we have here. We have result is equal to a random number right here. Remember, this is the smallest number you can get. So min, if min is the smallest number I ever want, I'm going to put here plus min. This is actually not the biggest number you can get. This is because remember, it's 1 less than this. So right here, the biggest number I would get from here would be 10. And I have to go one up. So if I put max here, I would never get max. It would be max one less than whatever max. So if max is, for example, if max is 15, then 15 times math.random at most would give me 14. So I'm gonna have to go one up. So what I'm gonna do here is I'm gonna say whatever max is, I want to add 1 to it. So let me try to give myself some space here. Plus 1. So whatever max is, add 1 to that. So if max is 15, make it 16, and then multiply that times math.random, because the biggest number I can get would be when I multiply times 16 is 15. Now there is an issue here, but I want you to see it. We're going to return the result. I need to test this. So now let me show you how I'm going to compile first, and this compiles with no error. When we are gonna, now that we don't have the main method within the same SpinnerGame class, I haven't coded it here because these are not static methods. I need to instantiate, create an instance of a SpinnerGame, and so I do that by saying, declaring the name of the class SpinnerGame, and then you can call it whatever you want. So let's call it just game 1 or just game equals a new SpinnerGame. By default, there's always a 0 argument constructor. This is a 0 argument constructor. So default, there's always 1. And we're gonna say, I wanna test, I'm gonna do game.spin. That's the name of the class. And I need to give it a minimum value. This is the name of the method, I'm sorry, spin. Minimum value and a maximum value. They're both integers. So let's say that I want, the lowest number I want is at 3, and the biggest number I want is a 9. And so I would want to see numbers that are no more than 3, no less than 3, and no more than 9. Now the spinner, the spin method returns the integer, so I need to print that. So system.out.print, print what game.spin returns when I send it 3 and 9. I'm going to compile and run. Now I'm expecting an error, but I want you to see what's going on and maybe think about what happened. Notice here I got a 10. Let me clear this. A 3, okay, 3 is good. 8, that's still good. 6 is fine. 7 is fine. 8 is fine. 3, 12, there we go. 12 is not correct. We want the smallest number to be a 3, random number. The biggest number to be a 9. There's something wrong with our method. And so let's take a quick look here. Obviously, I gave you this implementation. I said min is the smallest number you can have. Max plus 1 times math.random is the biggest number you can have. But there is something wrong. If I suggest you maybe pause the video right now and try to see if you can come up with an answer. So if you want, go for it. It's a challenge. It's a good challenge. I am going to go over what's going on. Let me draw here a little bit. So this is what's going on. Okay, so remember random. Let me just, I'm not gonna write math.random. I'm just gonna write random. If I multiply times, I'm making these numbers up. If I multiply times 9, I'll get, the smallest value I'll get is a 0. The biggest number I'll get is an 8. Right? Now if I then say, okay, well, to that, let me add, if I add 3, well, what adding 3 does is it adds 3 to the minimum value. And so that would be 3 and 11. And so there's something that can be said here about our use of min and max. And so I'm starting to think, okay, well, if I want this to be the biggest, the smallest number, 3, what do I have to add to 3 plus what to get the biggest number, which would be 9, right? Remember, I want numbers between 3 and 9. And so right here, the biggest number that I can add to 3 and still get 9 would be 6. And so I'm thinking, okay, I want my random value to be a number between 0 and 6. Because if I add 3 to 0, I get 3. If I add 3 to 6, and it's getting a little messy, there you go, to 6, I get 9. And so I need to multiply math.random times the difference. 6 is the difference between 9 and 3. And so what I'm going to end up multiplying math.random is not by max, but rather max minus min. So 9 minus 3. And then I'm going to add 3. There's still one thing here that is not quite right, but we're getting there. The fact here is that this would be 6 times random. Remember, this is min. 6 times random plus 3. Again, the biggest number I can get here is a 5. The smallest number I can get is a 0. And so adding 3 to the minimum would be 3. Adding 3 to the maximum would be 8. And so I'm still not quite getting there. What I need to do here is add 1 to make it 7. And so I need to do max minus min plus 1. So this is the equation times random plus min. And so this is the actual implementation that we want right there. If you need a minute, pause the video, think about it, ask questions, so on and so forth. Let me go in here then, and we're going to say I want this to be max minus the minimum plus 1, and then add a min to that. And this would then give me a random number between min and max inclusive, which means it would include whatever min is, 3, and whatever max is, 9. Now let me compile because I've made changes to this code. Let me run here, and I would never expect to get a number less than 3 or greater than 9. Now let me actually, because it's a little hard to, I mean, we can be here forever. Let me do this in a for loop, something like for int I is 0, I is less than or equal to, or just less than, I don't know, let's do like 20 iterations, and then I plus plus. And then what we want to do is just put this in here. What's going to end up happening here is that we're going to execute line 8 20 times. And so we'll get 20 random values. And it's a little easier to see that you never get a number bigger than 9 and less than 3. And so there you go. You have 20 values. And notice the numbers here. All the random numbers are always between 3 and 9. Never more or less. Alrighty, so that's spin. That's basically all there is to it. Notice how simple this is. Very simple. It does require that you remember how we use math.random. It does require that you remember how we typecast. And then also obviously remember how we increase the limits and upper and lower limits. So that's it for that one. Now let's take a look at play around, because this one is a little more interesting. It's actually not a hard implementation, but requires a little more thinking. Okay, play around. There's a lot to be said here, but I would suggest that you pause the game right now, or pause the video, I'm sorry, and just read what's being asked of you to do, and then you can follow along. I'm not going to spend too much on the explanation. I've read it myself. Here's the key: there's the player and the computer, and the player will spin the spinner and get a number between 1 and 10. while the computer has a spinner that only has numbers between 2 and 8. So the spinner, I don't know, think of it as, well, I don't know, a physical like little spinner that you can spin with your fingers like a die, and you only have these values. So player is always going to be between 1 and 10. Spinner is always going to be the computer is always going to be 2 and 8. And so right away, I'm starting to look at creating two variables, player and computer. And so I'm going to go in here and I'm going to say they're both integers. The player is the integer from spinning the spinner randomly, and so I can just execute the spin method. That's this method. It returns to me an integer that is a random number between min and max inclusive. And so I'm going to say, give me a random number between 1 and 10, like that. So that's player. And then the computer, which I'm going to abbreviate, is also, I'm going to just spin, but now I only want random numbers between 2 and 8. So that takes care of that. Let's compile here, verify that there's no issues with our code. I can only run the class that has the main method in it. So the SpinnerGame test, I can run this class, I cannot run this class. Okay, let's continue. If player 1 obtains a higher result, so this is you have the if condition right here, it's spelled out for you. If player 1 obtains a higher result than the computer, then the player gains the number of points equal to the positive difference between the spins. And they give you an example. So if player 1 spins a 9 and the computer spins a 6, you're gonna give the player 3 points, the difference. 9 minus 6 is 3. And so you would print this. Print the string, you win, 3 points. Okay, so it's if player is greater than comp, print this right here. So let's look at that. It's actually a very simple if statement. If player, whatever that number is greater than comp, whatever that is, we want to print. Now we might have to make some changes later on, but for now, let's just code it, test it, see how it works. Okay, we're gonna print this. I'm gonna go here. I always get messed up. There we go. Now there's something here that we need to change. 3 points is hard coded. We don't know if it's gonna be 3 points. Say maybe the player gets 10 and the comp gets 2, so the player would get 10 minus 2 is 8. So we don't want to hard code this. We're gonna terminate the string here, plus and here I want the difference, and so the difference is simply player minus comp. Okay. I'm going to compile it to verify there's no errors. There is. Okay, so let me try this here. I put parentheses because I'm trying to perform a mathematical calculation here, an arithmetic calculation within a print statement. Because notice this plus right here says this string plus this value, but I had a minus in there, and so you need to put this within parentheses. Okay, so I believe that codes the first scenario, the first row. Then if you can keep reading, but it says that if the player 1, the player's number is less than the computer's number, the player loses that amount of points, and you put a negative there. Okay, so let me do an else if. I'm going to say else, because there's more conditions, so I'm not going to just use else. I'm going to do else if the comp is greater than the player, or you can say player less than the computer, whatever you want. Let me copy this here, and it's going to say you lose. And there's a negative amount of points, so I'm going to put a minus here. I'm going to actually put negative right there, and I'm going to subtract because I know that the computer is more than the player, so I'm going to put comp minus player. So say the computer gets an 8 and the player gets a 3. So that would be you lose. And then negative, right here is the negative. And comp 8 minus player 3, that would be 5, negative 5 points. Okay, let's once again take a quick look. We're going to test all this, but here's where it gets a little interesting. If you get a tie, so you both roll the same number. Excuse me. Let's look at that. In the event of a tie, the player and the computer each spin the spinner a second time. So you need to spin again. If the sum of the player's 2 spins are greater than the sum of the player's 2 spins, the player gains 1 point. If the sum of the computer's 2 spins are greater than the sum of the player's 2 spins, then the player loses 1 point. And then in event of another tie, so a second tie after the 2 spins, the round is reported as a tie and the player's score does not change. Alrighty, okay. So we're gonna only have to account for 1 tie. And then if you tie again, then you just tie. We need to spin again. So we're gonna go in here. Okay, let's do an else. I might actually need an else if, but for now, I'm gonna put else because if player is not greater than comp, and if comp is not greater than player, then it's true that they must be the same. I'm gonna put the curly braces here because I think more than one line of code. In these, it was just a one-liner. Okay, so I know at this point that if this is not true and if this is not true, then I must be in a tie. And so I need to spin again. And I need to add my second spin to my first spin. This is the first spin for the player. Whatever I get, I need to add to my second spin. And so I don't want to make another variable. I can just say player equals what it used to equal. So player, whatever you got on the first spin, plus a second spin, which I would put here spin 1, 10. I want to add the 2 spins, okay? And then I can do the same here, comp. Now there's a shortcut, remember, if I'm going to do comp equals comp, you can just do plus equals itself. And then I'm going to spin, and for the computer, can only get numbers between 2 and 8. This is the short way of writing comp equals comp plus spin. And I can do the same here. I can just put here plus equals player equals itself plus a second spin, comp equals itself plus another spin. Okay, and then I need to check again if the sum of the 2, because I've added right here you've added the first spin with the second spin. Remember, let me put it so that it's a little easier to follow. I don't want to confuse you. I'll do the same here. This is my first spin. It's whatever I got in my first spin up here. And then right here is the second spin. And so I've added the 2 values. And again, this is my first spin for the computer. And here's the second spin. And I've added the 2. And there's, if the sum of the 2 spins for the player, so I'm going to once again do a comparison. If player is greater than the comp after 2 spins, it's a simple one line of code. I'm going to copy this and I'm going to look at this. You win 1 point, only 1 point. So if you add the 2 spins for the player, you earn 1 point if it's bigger than the 2 spins for the computer. So you win 1 point. Okay, you win positive. And I can hard code this because it's just going to always be 1 point. 1 point. They have a typo. Else, if the computer the 2 spins from the computer are greater than 2 spins for the player, then the player loses 1 point, just 1. We can hard code it. You lose -1 point. Finally, if the 2 spins for the player are not bigger than the 2 spins for the computer, and if the 2 spins for the computer are not greater than the 2 spins for the player, that means that we're in a tie. Else, and when we're in a tie, we want to just say you tied and you get 0 points, which is the last scenario here. You tie. 0 points are awarded if you tie for a second time. And so I'm going to come in here and I'm going to put here tie, 0 points. Now you might ask yourself, how are we going to test this? Well, let's try it out. What we need to do is basically we need to run the play round method more than once to try to see if we can get a tie, and then we want to see if we can get more than 1 tie. So I know that if I win 1 point, I may have tied. Not necessarily, because right here I could have also have 1 point. Actually, look, here's how I know. This is how I know I'm gonna have tied at least once, because right here I have points plural, and right here I have point and point. So if I see this print out on the screen, I know if I see point without an S, I know that I hit this condition. -1 point without an S, I know that I hit this condition. And then tie with 0 points, I know that I basically tied twice. So I'm gonna compile. I believe that's it. Spin, I deleted the S. It tells you what line, by the way, line 39, in case you've never looked at this. Java, SpinnerGame.java, line 39. There's something wrong here, I forgot the S. Okay, good. Now I'm gonna go to the spinner test, and just like I had here, where I wanna test the play round. So I'm gonna say from my game object, I want to play a round. Notice that there's no arguments in the parentheses. There's no numbers in the parentheses because the play round method has no parameters. There's nothing in the parentheses. There's no variables. Unlike in the spin method, there's 2 arguments, 2 integers. And so I had to send it 2. This returns an integer, so I had to print in the test class. I had to print that. The play round doesn't return anything. It's void of a return. And so I just need to execute it. Now, running 20 times, I would expect at least 1 tie, hopefully multiple ties. So I'm going to compile here, and then I'm going to run. There we go. So, okay, let's look here. Right here, you lose. And then you lose, you win. Notice how it's all plural right here. Points, 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 points. I'm looking for one that is not plural right here. This is a case where we tied on the first spin and we spun again, and the player lost. And then here we go again. This is the case where we spun once, tied, we spun again, and when we added our 2 spins, we still tied with the computer. That does it for this video. If you have any questions, please reach out to me.